Hello. In this video, I would like to discuss methods for finding rational roots in a polynomial equation. Recall that the fundamental theorem of algebra states that if p of x is a polynomial of degree n greater than or equal to 1, then the equation p of x equals 0 has exactly n complex number roots, including multiple roots. Therefore, linear polynomial equations, which have a degree of 1, have one solution, and it is found by simply solving for the variable in a one- or two-step process. Quadratic equations, which have a degree of 2, have two solutions, and these are most often found by factoring, completing the square, or the quadratic formula. Polynomial equations, where the degree n is greater than or equal to 3, have n number of solutions, and we often utilize the rational roots theorem to help solve. The rational roots theorem indicates that polynomial functions have a finite number of rational roots. It also indicates that the integer roots of a polynomial must be factors of the constant, which is noted with the a subscript 0 symbol in the equation above. Finally, the theorem indicates that rational roots must be of the form p divided by q, where p is a factor of the constant and q is a factor of the leading coefficient, written with a subscript n in the equation above. When solving polynomial equations and using the rational roots theorem to do so, we often create a list of all possible roots and check them with a calculator. Then, with solutions identified, we can factor and identify any irrational or imaginary number solutions that follow. Here is an example of a polynomial with a constant 24 and a leading coefficient of 1. So the first thing that I'll do is list all factors of the constant and all factors of the leading coefficient. There are many factors of the number 24. And recall, if there are any integer number solutions to the polynomial, they will exist in this list. Rational number solutions will occur in the list created by dividing factors of p by each factor of q. You must be careful here and consider every element of the set of factors of p divided by every element of the set of factors of q. In this case, our list of factors of p divided by factors of q is exactly the same as just the factors of p. We will use a calculator to evaluate the polynomial at each of these numbers because the factor theorem from a prior lesson indicated that when a function evaluates to 0, then we have found a solution to the polynomial, and also a linear factor. We are only interested in those values that evaluate to 0. All others can be ignored. I'm going to create my list first, then ask you to pause the video and resume playback in a moment after you've checked for solutions. Only the number -2, +1, and -3 evaluated to 0. Therefore, there are only 3 rational solutions. But this polynomial has a degree of 5. Therefore, while 3 solutions are rational numbers, 2 solutions must be irrational or imaginary numbers. We could use synthetic division to reduce the size of the polynomial to find the other zeros, but we will not do so in this video. In the next example, we have a constant that's equal to 5 and a leading coefficient that's equal to 2. So again, we must list the factors of these two numbers. The possible rational solutions will be of the factor p divided by q, and that list will look like this. Notice that each number in the list of factors of p was divided by each number in the list of factors of q. Positive and negative 1 divided by 1, 5 divided by 1, 1 divided by 2, and 5 divided by 2. We will use a calculator to evaluate this function at each of these numbers. Again, any value that evaluates to 0 will be noted as a solution to the polynomial. Please pause the video now and check your work in a moment. The only rational number solution to this polynomial is the number -1. Please try the final problem on your own, and be sure to list all factors of the constant and all factors of the leading coefficient. Then divide each of these factors by one another to produce a list of potential rational solutions. Finally, check this list of possible rational solutions with a calculator to find the actual rational solutions. Pause the video now and resume playback in a moment to check your work. Good luck. And here's an extra tip. This polynomial was a polynomial of degree 3, so I know that there are only 3 solutions to the polynomial. If you're in the middle of checking for solutions using the rational roots theorem, and you find 3 solutions, as we have done here, there's no need to check the remaining solutions in this polynomial. Thanks for watching.